Hello everyone, I hope all of you are doing fine. In the previous video, I showed you a step-by-step formula in terms of how you have to install TensorFlow on your Apple-powered device, that is MacBook Air M1, MacBook Air M2 and the other devices that follow the ARM architecture. This entire process won't work on the Intel architecture, which is where the speed ups that you're getting is all because of the new silicon that Apple has introduced. In today's video, I'll kind of go over a small benchmarking analysis in terms of how quick are the GPUs of Apple powered devices, that is the Apple Silicon devices, as compared to the NVIDIA GPUs that are freely available on Google Colab. So without wasting any further time, let me kickstart the video by showing you the Python code directly. So let's start. The first activity that I plan to carry out in the benchmarking analysis is to record the overall time taken to create a deep learning model on Google Colab. For this activity, I'm using the famous dataset, which is the Fashion MNIST dataset. Before I start the execution, one thing, if you are trying to replicate this at your end and you're doing this on Google Colab, make sure you have the GPU selected in the hardware accelerator section. So this is something that I wanted to specify before I go forward. Now I'll click on connect. So I have a session up and running. Let me start the activity by importing modules that I require. So I'll require matplotlib. I require Keras library as well. So here are the lines of code that I require in order to import the necessary modules. So let me quickly run the cell. So the import was successful. Let me go forward and now check if I have a GPU allocated to me or not. So the command for that is NVIDIA-SMI. So let me quickly execute this particular cell. So I have a Tesla T4 allocated to me. Sometimes you get a different GPU, but generally you end up getting Tesla T4 on a free account on Google Colab. So this is what I have currently running in my background. So the deep learning model that I create would be trained using this particular GPU, that is Tesla T4. Now I want to train the model on the GPU, which is where I require one more command, which is tf.config.set_visible_devices. And I pass in GPU as well as an empty list, which are the set of parameters that I require. So let me quickly run the cell. Now I'll quickly load the Fashion MNIST dataset. I could have picked up a more complex example, but given this is more of a benchmarking activity, I wanted to stick to a basic dataset, which is the Fashion MNIST dataset. So in order to load Fashion MNIST dataset into training and testing datasets, all I need is I have to call the command load_data and load it into corresponding variables. So let me quickly run this cell. So the data has been downloaded and saved into corresponding variables. Now just to check if the dataset is correct in terms of integrity, let me check the shape of xtrain, xtest, ytrain and ytest. So let me quickly run the cell. No errors, that simply means that I have the right data set in place. Let me go forward and show you the first training image as well. So this is an image of a shoe. And if I show you, and now if I go and show you multiple other images as well, this is what we have. So we have a total of 9 images. You have a shoe here, I have a t-shirt here and the other classes that follow as well. Before I go forward and create the model, there's some amount of pre-processing that is required, which is what I'll achieve using this particular piece of code. I basically have to reshape my entire data set so that I can kind of do batch-wise training. So which is where what I do is I say xtrain.reshape. 60,000 samples is what I have. Every image is of the size 28,28, which is what I have loaded here. And I add a 1 to add one more dimension to my data set. So when I quickly run this, this is the data set shape that I've generated right now, which is what is required for training. Similarly, I kind of reshape ytrain and ytest and also apply two categorical because I have categorical variables in my ytest and ytrain. So in order to convert those categories into numbers, I use a two categorical function from TensorFlow. So I'll quickly run the cell as well. Now we reach at the model training piece. So just to give you a heads up, what I've done is I've created a class of sequential and I've saved it as a variable called as model. I've added convolutional layers, pooling layers. I've defined various kernel sizes as well. And finally, I've added a flatten layer and a dense layer. And the overall dataset has 10 classes, which is where you have 10 here. So I want to predict 10 outputs and then apply softmax at the final output layer as well. So all of this is creating the model. Fairly simple model. I think I've created more complex models in my other videos. Feel free to check those out as well. But here, this is a fairly simple model. So not pondering over it too much. I'll quickly run this cell. Now I want to look at what the model is. So I want to quickly have a summary of the model, which is where I call the model.summary function. So here is where I have a summary of the model and how the entire output shape of every layer would be. Given I'm training the entire network from scratch, my total parameters are equal to total trainable parameters. So that is something that I have here. And finally, I compile the model with a particular loss, optimizer and matrix. So I'll quickly run this cell as well. Given that I'm doing a benchmarking activity, I wanted to train it for a finite number of times so that there is coherence when I do it on Apple GPU as well. So what I've done is in the first line of code, I start a timer. I start the training process in the second line of code. As soon as my model has been trained on 10 epochs, I stop the training. I end the timer and save the time into a variable called as E. Finally, the difference between end time and start time will give me the overall training time for this particular model. So this is all that I have done in this particular 10 lines of code. So let me quickly run this. So the training is now complete and the total training time on Google Colab with a Tesla T4 is around 622.52 seconds for 10 epochs. Let me now quickly show you the overall testing accuracy as well. So we have a model which is around 87% accurate that has been trained on 10 epochs and the overall training time that it has taken is around 622 seconds. And now let's see how much time it takes to run the entire execution, which is 10 epochs of the same model, same dataset on an Apple powered device. So this is the notebook that I'm running on my Apple MacBook Air M2. I have access to the GPU. So essentially what I'll do now is I'll run all the cells that I executed in the previous Google Colab section into this particular section. So I won't go in depth of every section, but I'll quickly start running each and every cell. So finally we've reached the training section. So let's start. So the total training time on Apple Silicon GPU is 99.44 seconds. We just ran this piece of code in a Tesla T4 powered Google Colab session and the overall time taken for the entire execution was 622 seconds there, and here it's taken merely 100 seconds. I'm seeing a speed up of more than 6 times here when I use Apple's Silicon GPU as compared to a Tesla T4. This is a significant bump up of performance that we are getting at a low power, at a low area density when I compare it to Tesla or NVIDIA powered GPUs. I am truly mesmerized with this kind of performance. Now, when I look at the accuracy on the testing data set, it again turns out to be the same, which is around 87%. Wow, I'm getting a speed up of around 5 to 6 times when I use Apple Silicon over NVIDIA's free GPUs. There are NVIDIA GPUs that would definitely beat Apple Silicon, but imagine the form factor wherein you're getting this computation power. All of this is in a lightweight 1.2 kilogram device, which is where the entire result blows me away. This is something that I wanted to share with all of you today in today's video. I wanted to give you a benchmarking analysis regarding how much speed up you can achieve when you use Apple's GPU as compared to NVIDIA's freely available GPU. So this is all that I had in today's video. I hope you enjoyed today's video. If you like the content that I create, it would be super motivating if you can press the subscribe button and also press the bell icon to be notified for amazing videos on data science and machine learning. Thank you so much for watching the video.